The height of an object falling in a vacuum, it can be found using this function, a negative 16t squared plus 30t plus 205, where t represents the time in seconds where the object begins its descent. And if the function now changes to this function, it used to be this function, but it changes to this one. Okay, what statement describes the change? So we have my first function and we have my second function. Okay, and the difference between it are these two numbers right here. So I really don't want to think about these numbers. Okay, in fact, let's change the sign of this to a plus and a minus and a minus. So I can, well, let me show you. If you change the signs of all three of these, what am I doing? I'm distributing a negative onto all three of these. Okay, copy down the first equation again. Change the signs of all three numbers here. It was a plus, it was a minus. It's going to change to a plus. Okay, this was a plus 30. When you distribute that on it, it changes to a minus. And this was a plus 205. When you change the sign, it becomes a minus. Okay, so what we have here, when we add these up, we get a minus 55. Okay, and it has nothing to do with time. It has to do with the feet. Okay, so we are starting what, 55 feet what, lower than we used to be, aren't we? Okay, we're not talking about velocity or acceleration. This is velocity here. This is acceleration. So this is feet per second, and this is feet per second per second. This is acceleration. This is velocity. This is the height, okay, in feet, okay? All right, so of my four statements, we went down. We're starting what? 55 feet what? 55 feet what? Lower. We're not going higher because we're going down 55, and we're not dealing with feet per second. We don't do 55 times t. We don't do 55 times the time. This is height here, okay? And it has to do with altitude, not the speed. So we eliminate h and j, okay, because that's the speed. We're talking about 55 feet what? Lower.